Good morning all. This is Dr. D. Khalandar Basha, working as Associate Professor in the Department of ECE, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today I am going to discuss the interrupts supported in 8051 microcontroller and the SFRs corresponding to interrupts we will discuss in today's session. The slides are prepared by referring the textbook, the 8051 microcontroller by Kenneth Ayala. An interrupt is an external or internal event that interrupts the microcontroller to inform it that a device or a process needs its service. A single microcontroller can serve several devices by two ways. One is polling, another one is interrupts. The first method, polling. The microcontroller continuously monitors the status of the given device, whether interrupt is generated by the devices or not. When the conditions are met, it performs the service. After that, it moves on to the monitor the next device until each device is served. The polling method is not efficient since it wastes much of the microcontroller's time by polling devices that may not needed service. For the polling method, it is not possible to assign priority since it checks all the devices in a round-robin fashion. The second mechanism is interrupts. Whenever any device needs its service, the device notifies the microcontroller by generating an interrupt signal. Upon receiving an interrupt signal, the microcontroller saves whatever it is doing and services the devices by executing a specific program for the device called interrupt service routine ISR. The advantage of interrupt is that the microcontroller can serve many devices. A device can get the attention of the microcontroller based upon the assigned priority. ISR, Interrupt Service Routine. The program which is associated with the interrupt is called the Interrupt Service Routine ISR or Interrupt Handler. For every interrupt, there is a fixed location in memory that holds the address of its ISR. The group of memory location set aside to hold the address of all the ISRs is called interrupt vector table. Towards the end of each mission cycle, the 8051 microcontroller checks each of the corresponding interrupt flag. The locations which are handled the interrupts by the microcontroller and its ISR address are given in the table. Reset the RAM location is 0000H. External hardware generated the interrupt on INT0 bar will have the ISR address at the address 0003H. For timer 0, the overflag which we are getting on TF0 for corresponding ISR we can find on the location 000BH. The external interrupt generated on the signal INT1 bar will have the ISR address at 0013H. For timer 1 overflow, we can see on timer overflow 1 flag. This, if it is generated, the ISR which is existing at 001BH will be executed. For serial communication, either for transmission or receiving, the interrupt will be recognized or given on the lines transmit interrupt and receive interrupt. If any one of the interrupt is generated when the transmission or receiving, the ISR at the address 0023H will be executed. The 8051 microcontroller has a total of 5 interrupts allocated. 2 interrupts are set aside for hardware and external interrupts. That is P port 3.2 and port 3.3 are for external hardware interrupts which we are getting on the lines pin numbers INT 0 bar and INT 1 bar. External interrupts 0 and external interrupt 1. Two interrupts are set aside for the timers, as 8051 is consist of two timers, timer 0 and timer 1. One of the timer 0 and one for the timer 1, there are interrupt requests. Serial communication has a single interrupt that belongs to both receiving and transfer. The reset pin of 8051 may also considered as external interrupt source functionality to set the PC for the ISR address with the ISR address 0000H. The various external interrupts. Reset. Reset is the highest priority interrupt. Upon reset, the 8051 microcontroller start execution code at address 0000H. Internal interrupts causes because of the timer, we'll call as timer interrupts. 8051 has two internal interrupts generated by the timers, namely timer 0 and timer 1. Whenever timer overflow flags TF0 for timer 0, TF1 for timer 1 are set. Then the microcontroller jumps to the vector address to serve the ISR. This global and timer interrupt should be enabled. Serial interrupt. 8051 microcontroller has a serial communication port and have related serial interrupt flag, transmit interrupt on TI, receive interrupt on RI. When the last bit, stop bit of byte is transmitted, then the transmit interrupt, serial interrupt is set. When the last bit, that is stop bit of the receiving byte is received, then the receive interrupt flag will set. There are two SFRs corresponding to interrupt handling in 8051 microcontroller. One is interrupt enabled register, another one is interrupt priority register. First, we will discuss the IA register, which is interrupt enabled register. The IA register is used to enable or disable the interrupt services corresponding to 5 interrupts which are supported to 8051 microcontroller. The IA register is 8-bit byte. The bits are bit 7 for enabling the interrupt EA, bit 6, bit 5, there is no significance, no bits are allocated, bit 4 corresponding to serial communication, bit 3 corresponding to timer 1, bit 2 corresponding to external interrupt INT 1 bar, bit 1 corresponding to timer 0 overflow, bit 0 corresponding to external interrupt on INT 0 bar line. The bit 7, which is EA, which is used for enabling all the bits. If you want to access or enable the interrupt requests or services by the 8051 microcontroller, we have to program EA bit is equivalent to 1. If EA bit is equivalent to 0, even if we enable any one of the 5 interrupts, interrupt services will not be considered because enabling of the interrupts are not done. At least to handle any interrupts, one interrupt or all the 5 interrupts, we had to configure the EA bit is equivalent to 1. When EA bit is equivalent to 1, it will enable all the interrupts. If EA bit is equivalent to 0, it will disable all the interrupts. Bit 6 and bit 5, they are not having any significance, they are reserved bits. Bit 4 corresponding to ES, which is to enable serial interrupt bit. When ES bit is equivalent to 1, it will enable the serial interrupts, that is transmit interrupt and receive interrupt. If the ES bit is equivalent to 0, it will disable the serial interrupts, that is transmit interrupt and receive interrupts. Bit 3 corresponding to ET1. ET1 stands for enable timer 1 interrupt flag. If ET1 is equivalent to 1, it will enable the timer 1 interrupts, that is timer overflow on TF1. If ET1 is equivalent to 0, it will disable the timer 1 interrupts. Next, bit 2, which is EX1, which is for handling the external interrupt on INT 0, INT 1 bar. This EX1 enable the external 1 interrupt bit that I can take as INT 1 bar. If EX1 is equivalent to 1, it will enable the external interrupts, that is, we can receive the interrupts on INT1 bar. If EX1 bit is equivalent to 0, it will disable the interrupts on INT1 bar. The next bit is bit 1, which is ET0 corresponding to timer 0. This ET0 bit enables the timer 0 overflow interrupt flag. If ET0 bit is equivalent to 1, it will enable the timer 0 interrupts, that is timer overflow for timer 0 TF0. If ET0 is equivalent to 0, it will disable the timer 0 interrupts. The LSB bit 0, which is for EX0, which will enable the external interrupt bit on INT0 bar. If you configure EX0 bit as 1, it will enable the external 0 interrupts. That means the interrupts will be accepted on the INT0 bar line. If you configure EX0 bit as 0, then it will disable all the external interrupts which are getting on INT0 bar. The next SFR corresponding to the priorities. Out of these 5, if more than one interrupt is generated, then how to handle the interrupts, which one has to be served whenever we have more than one interrupt request. So for that, we can assign the priority for the interrupts by configuring IP register. IP register stands for interrupt priority register. Priority to the interrupts can be assigned by using the interrupt priority register IP. The IP register is 8-bit wide. The bit configuration is shown in figure 5. MSB bit, bit 6 and bit 5, they are not having any significance, they are reserved bits. Bit 4 corresponding to priority for serial communication. Bit 3, it is for priority for timer 1. Bit 2, it is for priority for INT1 bar. Bit 1, priority for timer 0. Bit 0, priority for INT0 bar. The bit 4, which is PS, serial interrupt priority bit. If we configure the PS bit as 1, it will assign a high priority to serial interrupt. If PS bit is equivalent to 0, it will assign low priority to serial interrupt. Bit 7, bit 6, bits 5 are reserved bits. It is not having any significance corresponding to the priority. Next, PT1, which is on bit 3, which is for timer 1 interrupt priority bit. If PT1 is equivalent to 1, it will assign a high priority to timer 1 interrupt, that is timer overflow 1. If PT1 bit is assigned as 0, it will assign low priority to timer 1 interrupt. Bit 2, which is PX1, corresponds to external interrupt 1 priority bit. If PX1 is equivalent to 1, assign a high priority to external interrupt, that is on INT1 bar. If PX1 is equivalent to 0, it will assign a low priority to external 1 interrupt. Bit 1 corresponding to PT0, which is timer 0 interrupt priority bit. It will assign a high priority to timer 0 interrupts. If PT0 is equivalent to 0, assign a low priority to timer 0 interrupt. Bit 0, which is PX0, external interrupt priority bit. It is for assigning the priority for INT0 bar. Whenever PX0 is equivalent to 1, it will assign a high priority to external 0 interrupt. If PX0 is equivalent to 0, assign a low priority to external interrupt. Thank you. So in this session, we have discussed the various interrupts occurred for 8051 microcontroller and the SFRs corresponding to interrupts in 8051. Thank you all.
Like, share and subscribe. Hit the bell icon for more updates.